Hello everyone, here's a short little video on the reference angles that we skipped earlier in the unit. What is a reference angle? Let theta be an angle in standard position. Okay, so let's fill this in here. Standard position. Oh boy. It's pretty bad. The reference angle is the acute angle theta prime. Acute angle theta prime formed by the terminal side of theta. Terminal side of theta and the x-axis. It is important to note the reference angles are always positive. You can never, ever have a negative reference angle. That's just bad math, okay? And then they have 3 pictures here to show you how to find these reference angles. Remember what a reference angle is. It is so important to memorize this definition and to understand it in practice. Reference angles have to be acute. They have to be less than 90. They're the little bitty angles, okay? How do you find the reference angle? The reference angle has to be sandwiched between the x-axis and the terminal side of the original angle. There's only one possibility if you draw it as it is said. You have to have it anchored on the x-axis, and it has to also reach the terminal side. Boom, there's your reference angle. Just give it a positive number each time, and you are good to go. Notice that even when, like right here in this second example, right here, the reference angle is underneath the x-axis, but we still give it a positive value. That is important. Let's move down, take a look at a couple of these. I'm going to leave those pictures up for us. Find the reference angle, theta prime, and sketch theta and theta prime in standard position. Okay, so the first thing I'm going to do is sketch my angle. 300 degrees. Oh boy. Okay, well I know I start here, right? I always start here. And then I go around counterclockwise to 300 degrees. Well, what are my degrees? Let's see. This is 90 up top. This is 180. This is 270. So I would probably end at 300 degrees is going to be roughly right here. Following it all the way around right to there. That's going to be my 300 degree angle. It's not my reference angle though. I need theta prime. How am I going to come up with theta prime? Think about your definition. It has to be right here and on the x-axis. Well, I have 2 different ways to draw it on the x-axis, right? I could sketch it along here on the positive x-axis to the right, or I could sketch it over to the left. But it has to be acute. Therefore, the only option for theta prime is right there. Do not make this difficult, people. I have no patience for this. How do I find the measure? Well, lots of people use common sense here. They do have these formulas up here at the top. You're welcome to think about the formulas or just do your common sense. If we've already gone 300 degrees, what's left? 60 degrees. Really and truly, since I'm in quadrant number 4, I'm supposed to be using this last one over here that says 360 degrees minus theta, which is 300 degrees, which would leave me 60 degrees. So theta prime is equal to 60 degrees. My prime isn't showing up very well. There we go. Next one. Negative 135 degrees. I start here. Oh, that's terrible. Hold on just one moment. Let me see if I can erase that. That's just bad. Okay, so I start right here. Negative 135. Well, there's 90, there's 180, so I'm kind of halfway between the two, right there. So here we go. Woohoo! There is my original angle of negative 135 degrees. It's time for the reference angle. Reference angle has to be here, and it has to be on the x-axis. Well, the obvious choice is right there because it must be acute as well. So that is my theta prime. How do I find that number? Again, go back here to the top and check out your formulas or kind of use common sense. You know that a semicircle is 180 degrees, so when you take the difference from 180 to 135, you should get 45 degrees. Some of you may even already have most of this memorized from last time, or your last class rather, with the unit circle. All right, let's see. I don't want to do everything in degrees here. Let me scroll down. You can finish 3 and 4 yourself. At this point, you're going to lose that picture. You can always pause it and go back if you need it. How about we do, what looks ugly here? How about, I definitely want you to try number 8. Let's do, you already have 2 negatives. Let's do 6 and 7. I'll do 6 and 7. Why not? Whoops, my bad again. One day I'll learn how to use this app, folks. All right, angle, 4/5 pi. Let's see, 4/5 pi. Again, I know I have to start here. Where do I go? How far is that? Well, this is pi, and I didn't go 5/5 pi. I went 4/5 pi. So it's probably roughly right about there. These are sketches, folks. It's really not that serious. It doesn't have to be 110% perfect. It just has to be close enough that I can tell that you know what you're doing. So 4/5 pi is my angle. Now I need my reference angle. Has to be on the terminal side. Has to be acute on the x-axis. Wow, again, that's just terrible. There we go. Trim that up a little bit. So there is my theta prime. What is my measure of theta prime? Well, the entire half circle is 1 pi, and so pi minus 4/5 pi leaves me with 1/5 pi, or pi over 5. So pi over 5 is my measure of theta prime for number 6. Number 7, here we go again. Start here. Where am I going to? Ooh, this is a negative 11/9. Well, right here would be 9/9, right? Because I know that's 1 full rotation. And then I need to go 2 more 9ths. Ew. How about, let's see, 9, 18. Half of that is right there-ish. It's pretty good. Not fantastic, but again, close enough. So that's negative 11 pi over 9. That's my original angle. I need theta. Excuse me, theta prime, I'm sorry. Terminal side, boom, x-axis. There is theta prime. What is that measure? Well, I know that 9/9 is 9/9 pi, is 1 pi, so that's half, and so I went an extra 2 pi 9ths past there. So the value of theta prime is 2 pi over 9. It's a terrible looking 2 pi over 9. Sorry about that. All right, I'm going to let you finish this up for class.